Hello everybody. On this video, I will begin the discussion of fractions. For a lot of us, fractions are a source of embarrassment. We generally begin to learn about fractions at a very young age, so people mistakenly believe that it must be a simple concept. But there is no reason to be embarrassed. Fractions can be challenging. We will be using the concept of the greatest common factor in this video. So if you're unfamiliar with this concept, please take a few minutes to view video number 9 on least common multiples and greatest common factors. Let's begin with an introduction into the concepts and terminology involving fractions. Fractions refer to some portion of a whole unit. If we can subdivide an object into smaller portions, then those smaller portions are said to be a fraction of the original object. I use pizzas when I talk about fractions. We're familiar with pizzas, so that's a big help. Also, while there might be people out there who don't like pizzas, I haven't run into any of them yet, so that helps. Say I have a nice, freshly baked pizza and offered you some. It smells absolutely wonderful, and you happen to be very, very hungry. There are two questions which are really important to you. How many slices do you get? And how big are the slices? So when I write a fraction, I'm providing you with that information. I'm going to be drawing some pizzas for this illustration, but as a matter of expedience, I'll be leaving out the mozzarella and pepperoni. Sorry about that. Let's take a fraction like this. We can call it 3/8 or simply 3/8. The number on the bottom, 8 in this case, tells you how many pieces the pizza is cut into. It's called the denominator. The number on top, 3, tells you how many of those pieces you get. It's called the numerator. So in this case, you get 3 out of the 8 pieces that comprise one whole pizza. That should fill you up a little bit, at least. One of the concepts that is implied in this notation is that the pizza is divided into equal pieces. If the pieces are unequal, then the expression of 3/8 has very little value in terms of giving you an idea of how much of the pizza you have. Whenever we deal with fractions, it is with the understanding the fractional parts are always equal. If the numerator is larger than the denominator, then that means that you have more than one whole pizza. For instance, the fraction 3/2 means that you have 3 pieces where each piece is 1/2 of a pizza. That is, you have 1½ pizzas. We can write this equivalently using this notation. This is called a mixed fraction. A mixed fraction is where you have both an integer component and a fraction component in a single expression. Another example of a mixed fraction would be 2 3/4. This is equivalent to the fraction of 11/4. When we write a fraction in this manner, with the numerator larger than the denominator, it is called an improper fraction. I don't like the term improper fraction, since we generally have to convert a mixed fraction to an improper fraction before we perform any operation with it. So I'm not sure why a fraction with the numerator greater than the denominator is considered to be improper.
Excuse me?
Yes? Who's there?
I am the fraction fairy. I name all of the fractions.
The fraction fairy?
Yes, I believe I said that already.
Okay, thank you. Perhaps you can explain why we call fractions improper when the numerator is greater than the denominator.
Of course. It's none of your business.
That's it? None of my business?
Absolutely.
Okay then, I guess that's as far as we're going to get with that discussion. One of the first skills we want to be able to do is to convert improper fractions to mixed fractions and vice versa. So let's try a couple. Let's convert the improper fraction 31/7 to a mixed fraction. Please try to keep the big picture here. You have 31 pieces of pizza, where each pizza is cut into 7 equal pieces. So the first 7 of your 31 pieces makes up one whole pizza. The next 7 make up another pizza, etc. You have 7 plus 7 plus 7 plus 7 plus 3 equals 31 pieces. This equates to 4 whole pizzas with 3 pieces remaining. We write this as 4 and 3/7. This is a good way to conceptualize the idea, but normally we would take a more mathematical approach. We can use the long division skills we learned years ago. Some of you may be rusty, so let's go through it. Simply divide the numerator by the denominator using long division. 7 goes into 31 4 times. 4 times 7 is 28. We have a remainder of 3. So the mixed fraction is 4 and 3/7. I'm not sure that long division is being taught anymore, so for those of you who don't do long division, you would simply take the largest multiple of 7 that does not exceed 31. In this case, the multiple is 4 times 7 equals 28. Then take the difference between 31 and 28. The answer is 3, so we get the same result of 4 and 3/7. Let's try one more. This time I want you to pause the video to see if you can work out the problem yourself. Let's convert 17/5 to a mixed fraction. Pause the video now and then restart when you are done. Let's work out the answer with long division first. 17 divided by 5 is 3. 3 times 5 is 15. The remainder is 2. The mixed fraction equivalent of 17/5 is 3 and 2/5. Using multiples, the largest multiple of 5, which is less than 17, is 3 times 5 equals 15. The difference between 17 and 15 is 2, so the mixed fraction is 3 and 2/5. To convert a mixed fraction to an improper fraction, we multiply the denominator by the integer portion of the mixed fraction and then add the numerator. This gives us the numerator for the improper fraction. We keep the same denominator. Let's try this for 4 and 1/2. Multiply the denominator, 2, by the integer portion of the mixed fraction, in this case 4. 2 times 4 is 8. Now add the numerator of 1. 8 plus 1 is 9. The numerator of the improper fraction is 9 and the denominator is 2. 4 and 1/2 is equal to 9/2. Let's try one more. Again, pause the video and try to work this problem out yourself. Then restart the video. What is the improper fraction equivalent of 3 7/8? Pause the video. Okay, let's work it out. First, multiply the denominator by the integer portion of the mixed fraction. We have 8 times 3 equals 24. Then add the numerator. 24 plus 7 is 31. The mixed fraction is 31/8. How did you do?
This is quite simple, young man.
Great. Suppose you and I split the cost of a pizza. We each paid half, and so you would expect to end up with half of the pizza. That means that no matter how many pieces the pizza is cut into, you will be satisfied as long as you get half of the pizza. So if the pizza is cut into 4 pieces, you would expect 2 of them. If it were cut into 6 pieces, you would expect 3 of them. And if it were cut into 8 pieces, you would expect 4 of them. We can write all of this as fractions. 1/2 of a pizza is equal to 2/4, or 3/6, or 4/8. All of these fractions are said to be equivalent or equal to each other. For any fraction I choose, I can write as many equivalent fractions as I choose. There are, in fact, an infinite number of them. I can quite ridiculously cut a pizza into 78 equal parts. As long as you get 39 of those pieces, you will have half of the pizza. You probably won't be too happy, since by the time I cut the pizza into so many pieces and count out your portion, you will likely end up with a cold, jumbled mess. Still, you'll have half of a pizza. We simplify a fraction when we write it in an equivalent form where the numerator and denominator are integers that have no common factors. The fraction 2 over 4 is not simplified, since both the numerator and denominator have 2 as a common factor. In fact, the fractions 2 over 4, 3 over 6, 4 over 8, and 39 over 78 all simplify to 1/2. For any fraction we choose, we simplify it by dividing both the numerator and denominator by the greatest common factor. Let's try a couple of examples. Let's simplify the fraction 6 over 9. Step 1 is to find the greatest common factor between 6 and 9. It is 3. Next, we divide both the numerator and denominator by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. We have simplified 6 over 9 to 2 over 3, or 2/3. Let's try another. Let's simplify the fraction 25 over 35. Again, we start by finding the greatest common factor of 25 and 35. The answer is 5. Then we divide both the numerator and denominator by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. The answer is 5 over 7. One last example. Again, try this on your own. Simplify the fraction 56 over 98. Pause the video and resume it when you have solved the problem. Okay, let's work it out. First, find the greatest common factor of 56 and 98. The answer is 14. Next, divide both the numerator and denominator by 14. 56 divided by 14 is 4. 98 divided by 14 is 7. The answer is 4 over 7. How did you do?
Nailed it!
Okay. There is a final concept I would like to discuss. We can have negative fractions. For instance, it is perfectly acceptable to have a fraction like -2 over 9. Negative fractions are harder to visualize, but the concept and application of negative fractions are the same as for fractions comprised of positive numbers. When dealing with negative fractions, we can have the negative sign in the numerator, the denominator, or in front of the fraction. So all three expressions shown are equivalent to each other. There are some other properties associated with negative numbers that I will discuss in later videos, but I think we have covered enough of the basics of fractions to begin using them in applications. In the next video, we will talk about how to do addition and subtraction using fractions. Have a good day, everyone.
We hope to see you at Veterans Upward Bound very soon and recommend a friend.